this video, we are going to talk about interference of reflected light in thin films. So previous section, we talked about interference as well, but the interference happens between two lights that's transmitted through a double slit system. Okay, we call it Young's double slit experiment. But for now, the interference still occur, but it's between two waves that were reflected from the thin films. So later we understand why is there two waves that get reflected from a thin film. We'll understand all these details through this series of videos here. But let's try to recall a little bit of what we have learned about reflection and refraction first. So when light experiences a change of medium, it will get reflected and or transmitted or refracted. Okay, the idea of reflected means by it didn't manage to get through to the second medium, the light will get bounced back to the initial medium that the light was traveling in. If it's transmitted, then it means by it travels from a one medium to another medium. It gets passed through to the next medium. Okay, so if it gets passed through the next medium, refraction will occur. That's why we also call it as refracted. Okay, so to put it in the form of diagram, let's say the white region up here is medium 1 with an index of refraction of n1. The medium down here in blue color is medium 2, which is an index of refraction of n2. So let's say today you have an incident ray being incident on this boundary between medium 1 and medium 2. What will happen is a portion of the light will get reflected back towards medium 1, and a portion of the light will get transmitted into medium 2, or we say refraction occur and a portion of the light get refracted into medium 2. It's usually a combination of reflection and refraction both occurring simultaneously. That's why if you look out from the window of your home, you see a very faint silhouette or a faint reflection of yourself, but at the same time you are able to see what's happening outside. You're able to see what's happening outside because the light from the outside get transmitted, get refracted through the glass and come into your eyes. That's a refracted ray. But at the same time, you are also able to see light get reflected off the glass, and therefore you're able to see your own reflection. So usually when you encounter any kind of boundary, right, it's usually a combination of reflection and refraction. Of course, for certain material, you have a greater proportion of reflection, a smaller proportion of refraction, such as a mirror. Let's say mirror, almost all of the light gets reflected, almost a very minimal amount of light get refracted. And if you look into a very clear, transparent pond, maybe you're not able pond, like a pond of water. So if it's very, very clear, you can see inside, you can see all the fish moving inside, but you're not able to see your own reflection, then probably for those situations, the portion of light that gets reflected is very minimal. Most of the light get refracted. Okay, so it is a proportion of things, but it happens simultaneously. Both of these will happen simultaneously in the usual case. Okay, so now we're going to analyze it in the form of wave. Right now what we draw here is ray. The ray shows the direction of propagation of the light, but now we want to focus on the wave properties over here. Okay, because when we talk about interference and diffraction, it's all about the wave properties that we're talking about. Okay, so incident ray, of course, it has its own wave, but after that, your reflected ray, it will get reflected. So reflected, the reflection will look something like this. But there's one thing that you need to consider over here is whether there's any phase change that will occur for the reflected ray. Okay, so phase change means by whether your phase will be shifted. Let's say if it arrives at here with a crest, will it come out as a trough or will it come out also as a crest? Okay, if it comes out also as a crest, then maybe it means that there's no phase change. If it comes out as a trough, then maybe there's a phase change that occur. Okay, so you need to consider whether there's any phase change or not, because we know that if there's a phase change, then you talk about situation where they're in phase or anti-phase and things might get a little bit complicated. So there's first thing that you need to consider is whether there's any phase change that occur when you have light reflected off a boundary over here. Okay, the second thing that we are going to study is okay, so these are two possible options that I'm showing here. The blue wave here shows a version and the green wave here show a version. So one version is if there's no phase change, another version is if there is a half cycle phase change. We'll talk about this half cycle phase change in the next video, so don't worry too much about it. I'm just trying to tell you here what are we going to unpack in the next few videos later. Okay, so the first thing is whether there's any phase change when there's a reflection that occur. The second thing that we'll consider is we now know that there's also a portion of the wave that get transmitted to medium 2. We want to understand whether this wave that is being transmitted into medium 2, is there any change in the wavelength of this transmitted or refracted ray? Does the wavelength get shorter or does the wavelength get longer? And what does it depend on? Okay, this change of wavelength, what does it depend on? Okay, so these are the two things that we are going to study in the next video.